everybody. Alright, here is what we are going, or what you need to do for today. So the 10-4 inverses and determinants of a matrix. Okay, and then your homework, I'm going to give you the homework right now. So page 515, number 14, 18 through 25, all 30 and 33. And I'll try to make this as, simple and quick as I can. Okay. We're going to skip explore and reason. Okay, go right into the inverse matrix. So the inverse of a matrix is a matrix such that the product of the two matrices will give you an identity matrix. Okay, the product of the two matrices give you the identity matrix. This is the identity matrix that we talked about yesterday. So if you multiply two matrices and they give you the identity, then they're inverses of each other. Okay, this is just like you're used to the regular numbers. This is just like if you have 5 times 1/5, it gives you 1, which is the identity element. This is the identity for multiplication. Okay, for multiplication of real numbers. So you're used to this, you know this. So if you multiply a number by its reciprocal, it gives you the identity. In matrices, it's the same idea. Multiply a matrix by its inverse matrix, it gives you the identity matrix. Okay. Let's take a look at our first example. So explore the 2 by 2 matrices. So the question is, what is the inverse of this matrix, 2, 1, 3, 0? So we're going to write an equation. We don't know the inverse, so that's what we're trying to figure out. But we do know that if I take this matrix and multiply it by its inverse, which I'm going to designate as WXYZ, I don't know what it is. If I multiply those two, then I get the identity matrix. Okay, so I can use that. I can multiply the matrices on the left side of the equation. And then basically solve the equations. So here we go. That's a good review of our matrix multiplication. So first row by first column. So that's 2W, okay, plus 1Y. All right, then let's do first row by second column. That will give me 2X plus 1Z. Okay, then we'll do second row, first column. That will give me 3W plus 0Y. And then let's do second row, second column, which goes as my second row, second column here. So 3X plus 0Z. 3X plus 0Z. Okay, that matrix must equal 1, 0, 0, 1, the identity matrix. Okay. Okay, so here it is. So we're gonna map them. Now we're going to solve the equations that result from matrix multiplication. So I'm going to set each element of the first matrix equal to the corresponding element in the second matrix. This results in a system of 4 equations. Okay, for this particular system, I'm going to solve the equations that involve only one variable first. And let's map them here. So first element here goes with the first element here. So I'm just going to color code them. This one matches this one. So that's first row, second column. First row, second column in the second one. And then we have this one is equal to 0, and this element is corresponding with this element. So now we set a system of equations, but like this problem suggested, is we're going to solve only one variable first. We got the 0y here, so I'm going to pick that first and solve for w. 3w plus 0y equals 0. That's my first equation. I'm setting the corresponding elements equal to each other. Okay, of course 0y is not there, so 3w equals 0. So w is 0. Okay, I got my first element here in the inverse matrix. Okay, then the other one that has a 0 is this one. So I'm going to do that first. 3x plus 0z equals 1. So 3x equals 1. Therefore, x is 1/3. Okay, so I got my second, or my element here. Then I'm going to substitute w and x into the first two equations, which would yield, so we got here 2w plus y equals 1. 2w plus y equals 1. And I know w is 0. So I'm going to substitute the 0 here. And then solve for y. So y is 1. Okay, then the last one is the 2x plus z equals 0. Okay, so I know x is 1/3. And then I can get z. So get 2/3 plus z equals 0. So z is negative 2/3. Okay, so the way I had my inverse matrix written in the previous problem is I did w, x, y, z. I have to match, what I got. W, x, y, z is what I did. So w, x, y, z. And now I know all of them, so I got my inverse matrix. So it's 0, 1/3, 1, and negative 2/3. That's the inverse matrix here. And inverse matrix of the original one. That's inverse of matrix 2, 1, 3, 0 that was given. You know how you could check? Take those two and multiply them. You should get 1, 0, 0, 1. And if you don't, then we did something wrong somewhere here in the algebra. But it should work out. Okay? All right, so let's do the second example. Okay, find the inverse matrix of 1, negative 1, negative 1, 1. We're going to do exactly, the same process. So my matrix, 1, negative 1, and then negative 1, 1. That's the original matrix. I want to find its inverse. So w, x, y, z. That should equal 1, 0, 0, 1, the identity. All right, so we're going to do the multiplication here. So without color coding. Hopefully you got it by now. So first row, first column. So that's w minus y in the first row, first column. And then first row, second column. So x minus z. Okay, and then negative w plus y in the second row, first column. And then second row, second column would be negative 1 times x, which is negative x, plus 1 times z. Okay, that should equal the identity matrix. Okay, so now I don't have any zeros here. So I'm going to have to set up a system of equations. So let's put the w and the y's together. So we have w. This will give me w minus y. W minus y equals 1. Okay, so w minus y equals 1. And then we know negative w plus y equals 0. And then we have x minus z equals 0. Okay, and then we have negative x plus z equals 1. Okay, so back to solving systems, we can solve this by elimination. So if I add here, these go away and I get 0 equals 1. If I do add here to eliminate, also these cancel and I get 0 equal 1. Both of these are false. I cannot solve this system. Okay, there is no solution because I get false statement. So there is no solution. This means that this matrix is not invertible. The inverse does not exist. Okay, so the matrix 1, negative 1, negative 1, 1. The original one does not have an inverse. Okay, some matrices don't have inverses. Okay, and the next part of the lesson is figuring out how do we know if a matrix has an inverse or not. But before I do that, there is one more example because there's also elimination, and I want to do that example just to refresh your memory on elimination. So let's do this one. See if you can do it by yourself. You can pause the video and come back and check. Okay, what's the inverse matrix of this? So it's going to be 1, 5, 1, 3 times W, X, Y, Z. That equals the identity. Okay, so now I'm going to set up a system of equations. I'm going to set up the equations and the system. We have 1W, so W plus 5Y. For them, I'm multiplying the matrices now, these two. And here we have X, 1 times X plus 5 times Z. Okay, then here we have 1 times W plus 3 times Y. And we have 1 times X plus 3 times Z. That's the product matrix, and that should equal 1, 0, 0, 1. Okay, so then let's set up the system. So we got W plus 5Y equals 1, and we have W plus 3Y equals 0. And I have X plus 5Z equals 0, and then X plus 3Z equals 1. Okay, so again, the easiest way to solve this, well, you could do substitution or elimination. I'm just going to do elimination. Okay, so I'm going to multiply this by negative 1. Then I have, so the first equation, then I have W plus 5Y equals 1. This one becomes negative W minus 3Y equals 0. Add, and I get 2Y equals 1. So Y is 1/2. Okay. And I have to go back and find W. So I'm going to put a half for W here, so use either one of the equations, it doesn't matter. So W plus 3 times a half equals 0. So W equals negative 3 over 2. Okay, I got 2 letters. I need to get the other 2. Again, I'm going to eliminate here, multiply this by negative 1. So then we have X plus 5Z equals 0, and then I have negative X minus 3Z equals negative 1. Okay, this is eliminated. Then I get 2Z equals negative 1. So Z is negative 1/2. Okay, go back and find X. Substitute in either equation. And go with the top one. X plus 5 times negative 1/2 equals 0. I went with the top one because of the 0, and I went to the bottom one here because of the 0. It just makes the math easier. Okay, so then X equals, this is negative 5.5. So then add 5.5 and you get 5, X is 5.5. Okay, so my inverse matrix is going to be W is negative 3 over 2. X is 5 over 2. And then Y is 1/2. And Z is negative 1/2. That's my inverse matrix. Okay, how do you know if a matrix has an inverse or not? That's what we call the determinant of the matrix. Okay, you can do something with a determinant. Actually, no, take that back. We use the determinant of the matrix, of a 2 by 2 matrix, to find out if it has an inverse or not. We use the determinant. Okay, for a matrix A, B, C, D, the determinant of a 2 by 2 matrix A, denoted by DETA, that's determinant of A, is the value of A times D minus B times C. Okay, so AD, the main diagonal, minus BC. That's called the determinant of the matrix. Okay, the inverse of A is denoted as A negative 1, just like inverse functions, so same idea. And it exists if and only if the inverse exists if and only if the determinant of A is not equal to 0. So if I do this calculation and it's not 0, then the inverse exists. Okay? So if I have this matrix and A has an inverse, here's how you can calculate the inverse quickly. That's another way now to calculate the inverse. If I know the inverse exists because the determinant is not 0, then I can go ahead and get my inverse this way, using 1 over the determinant and then D, negative B, negative C, and A. Okay, so to make this easier, here's what's happened here to the original matrix. You swap A and D, so this becomes D and A, and then you switch the signs on B and C. Okay? Again, the original matrix is A, B, C, D. To find the inverse, you take 1 over the determinant of A. I'm just rewriting this up here, because then now I'm thinking about it as I'm writing it. Then you multiply it by a matrix that you get by swapping A and D. So DA becomes that way. And then you switch the signs on B and C. Leave them alone, you just switch the signs there. Okay? So let's find the inverse that way. All right, so what is the inverse of this matrix? Okay, so the inverse, I'm not going to calculate the determinant yet because that's part of finding the inverse, so it's 1 over. The determinant is AD minus BC. That's, okay, so let's put the numbers here. So this is A, B, C, D. So it's AD minus BC from the previous slide. So that's, okay, I'm getting ahead of myself. We'll do this calculation here in a bit. So the inverse is 1 over the determinant times you flip-flop, okay, the matrix, the A and the D. So this becomes 2, this becomes 4. And then I switch the signs here. So this becomes negative 1 and 1. Okay, so let's calculate the determinant. So I guess I'm going to calculate the determinant over here on the side. So AD minus BC is going to be 4 times 2 minus BC, 1 times negative 1. So this is 8 minus negative 1, which is 9. So 8 plus 1, which is 9. Okay, so the determinant is 9. Okay, so the determinant is 9. So the inverse is 1 over 9 multiplied by this flip-flopped AD matrix. 2, 4, opposite signs here, so negative 1, 1, and then now that's scalar multiplication. So this is just 2 9ths, and then negative 1 9th. 1 9th times 1 is 1 9th, and then 1 9th times 4 is 4 9ths. That's the inverse matrix of that. Okay? Let's do another one. B. What is the inverse of this matrix? You know what? I'm going to calculate the determinant first. Okay, so it's going to be, again, this is A, B, C, D. So AD, 6 times 4 minus BC. So 8 times 3. Well, that's 24 minus 24, that's 0. So the inverse does not exist because the first part of the inverse equation using the determinant is 1 over the determinant. 1 over 0 is illegal operation in math. So the matrix, the inverse matrix does not exist. Or this matrix, matrix B, does not have an inverse. Okay. So that's, you'll be required to do like a 2 by 2, finding the inverse of a 2 by 2 matrix by the process that we did here, or using the system of equations, depending on what the question asks for. Now, there is also finding the determinant for a 3 by 3 matrix, but that's tedious to do it by hand. It's doable by hand, but that's a little bit tedious. So we got a 3 by 3 matrix. Find the inverse of that. It's doable by hand, but it's just a lot of work. And we got technology that does it for us. So we are going to use a calculator to find the inverse of that matrix. Okay, so here are the steps. You can pause the video or look at the notes. These notes I posted on Canvas as well, as always. So I scanned this and I posted it on Canvas. And I'm gonna do just that. I'm just gonna follow this. Okay, so steps on the calculator. Okay, to find the determinant of a 3 by 3, or for that matter, any dimension matrix. So we're gonna do edit and then, or go second, and then x -1. Over here, second x -1 will get you to the matrix menu. So that's the first thing I'm gonna do. Then I'm going, you know what, I'm gonna go to edit. So scroll over to edit and then enter. I already had this from before, so I want to change it. So for you, it's probably going to be blank. Just tell it the dimension. I'm going to have a 3 by 3 matrix. Change the dimension to 3 by 3. So you go 3, okay, or 3, and then scroll over to 3. So that gives it 3 by 3. Okay, and then you go to enter the matrix. So just use the arrows here and just enter the numbers. So I'm going to go back and enter this way, matrix. So we got 1, enter. Enter will move to the other row. So you have 1, 2, 1. And then it goes to the second row. So 1, 2, 1, and then 0, -1. Be careful here. Don't use the minus sign. Use the negative sign. Not the minus, but the negative. Otherwise, it freaks out. Okay, and then 0. That's the second row. The third row is 2, 1, 4. So 2, 1, and 4. Okay, so I have entered my matrix, 3 by 3 matrix. That matches this one. Okay? Then we are going to go second mode to go back to the main screen. And then we go second x -1 or x -1 to go back to the matrix menu. Okay, then scroll to math. And then here you can find the determinant, the first option here. Choose option 1 for determinant. Okay, and it's asking you the determinant of what matrix. So if you remember in that menu, the matrices had names. Okay, and I put the matrix in my A. It was named A. So if I go back, this is what I'm talking about. Whoops. See how they had names? I want to find the determinant of matrix A. So I'm going to go back here and put matrix A. So to grab A, you're going to go back to second matrix, okay, and then choose option 1 for A. So I don't need to scroll to math or edit, just leave it because I want to pick up the name. Get A. Now it puts determinant of matrix A like that. Okay, I'm just following that. And then hit enter, and then voila. That's a determinant. It's -2. Okay, determinant of that is -2. Okay, so the next thing we are going to find the inverse of that same matrix, and it's just it's another menu, it's another option. So we already have matrix A entered and everything, so go second, and then go back to the matrices. Then I'm going to go I need the math menu. I already entered it, so this walks you over entering it again. To find the inverse, enter 3 by 3, enter the matrix. We already have all that. Go back to the main menu. Now we need to grab the matrix and find the inverse. Okay, so you go back to the matrix menu. Okay, choose matrix A. Okay, and then, no, sorry. Try again. So we go second matrix, go math, and then there should be an inverse here. Oh, no, it's not here. Okay, I'm sorry about this. I don't want to redo the video, sorry. Okay, go back to the main screen. I want to find the inverse of the matrix, okay? So we need to go to second matrix and then enter it if you don't have the matrix already entered, which you know how to do now, okay? Then I actually want to grab the name. So I want to grab A, okay, and then hit X1 without hitting X or anything, or second or anything. So I just hit this button, and this tells it, give me the inverse of that matrix. And then you just simply hit enter. And there is the inverse of that matrix. There we go. It's way easier than I thought. Okay, here it is. So 2, 3.5, negative 0.5, 0, 1, 0, negative 1, negative 1.5, and 0.5. If you want these to display as fractions, go math, frac, and then it gives it to you as fractions. Okay, so this is the inverse matrix for this one. Okay, all right. These are practice problems. You can practice with them if you would like. So here, again, the notes are posted so you can practice, check your answer. And then there's a really cool problem, but due to the asynchronous day, and then you're not going to be tested on any of this. If we have time in class at some time, I can show you. We can use matrices to encode and decode messages. Okay, it's pretty cool how it works. It is explained thoroughly, so if you're interested in that, take a look at the explanation. I can help you with that during prime or if we have time in class. But again, this is something cool. You're not going to be tested on it. And due to the duration of this video, I don't mean for it to be this long. I'm going to, stop the video. You can also practice finding the determinant with a 3 by 3 matrix in this triad using the calculator and instruction. But I'm going to call it good. I tried to make it short, but I just want to be thorough when I explain. So hopefully it's short enough for you. All right, and the homework is, I showed you that in the beginning of the video. Have a good rest of your day.